Hello everyone, I'm Anmol Kumar Urao, a student volunteer in Unnat Bharat Abhiyan in the Institute National Law University Odisha under the faculty advisor Dr. Kunti Rani Pradhan. This video lecture is on chemical reactions and equations, the first chapter of class 10 science. So when we talk about chemical reaction, it is a change in which one or more substances or reactants react to form a new substance with entirely different properties. Right? What are the daily life examples that we look into? First is that is burning of fuel. जब आप गाड़ी चलाते हैं, and then there is photosynthesis, there is digestion of food, and then there is respiration, right? So these are some of the daily life examples. And how do we identify a chemical reaction is on the basis of how whether or not they change their state, that there is a change in color, if there is evolution of gas, or if there is a change in temperature, and if there is formation of precipitate. Right. So this is how we identify a chemical reaction by the observation of any of these factors. Right. Moving on to next slide, that is chemical equation. It is a symbolic representation of a chemical reaction. Uh, Here, for example, sodium reacts with water to give sodium hydroxide and oxygen. We write it in this way that symbolizes that chemical reaction into chemical equation, which is the symbolic representation. And how do we write it is that we first give a skeletal chemical equation, and then we balance it, and then we add information to make it more informative. Right, moving on to the next slide, we have firstly that is writing a skeletal chemical equation. The sum of key information to note here is that this represents the change of reactants to products. This gives us the information that some a gas has evolved, which appears on product side beside a gaseous state, element, or a compound. Right. This shows us that precipitation will occur, and then there is LHS that shows that reactants are written with a plus sign, and RHS, that is right hand side, shows us products with a plus sign, right? So, for example, methane reacts with oxygen to give carbon dioxide and water. So this is a skeletal equation in which CH4 is methane, O2 is oxygen, CO2 is carbon dioxide, and H2 is water, right? And we have plus side on LHS, that is reactants, and then plus sign on the product side, that is RHS, and then we have this arrow representing that change of reactants to product has happened. Right, moving on to the next slide, we will look into how to write a balanced chemical equation and why do we do it. Firstly, why do we need to balance a chemical reaction is because law of conservation of mass, right? Which states that mass can neither be created nor be destroyed during a chemical reaction. Now, what it means is that since it is not getting destroyed, reactant's mass will be equal to product's mass, right? So, for this, we look into balancing the chemical equation. Now, while balancing, we follow certain steps. That is step one, writing an unbalanced equation, right? So, moving on to the next slide, we will take, for example, the example of zinc plus hydrogen chloride gives us zinc chloride plus hydrogen. Now, what is the next step that we look into? So the next step is enclosing the formula in brackets, right? Now we will enclose it into bracket and then follow the step 2, right? Step 2 says that making the list of elements as shown in the unbalanced equation, making list of elements. So we have zinc, we have hydrogen, and then we have chloride, right? So we will look here the number of atoms on LHS, that is reactant side, and RHS, that is product side, right? And we see here is that hydrogen is 1 in reactant side, and in the RHS, that is product side, we have 2 hydrogen. Chloride is 1 in product side, it's 2. Okay, so to balance the first element, that is step 3, we look into element having greater number of atoms, right? So we have hydrogen and chloride, which has greater number of atoms, right? So what we do here is we either add 2 or multiply it by 2, and then we look into whether or not something changes, right? So since we multiply it by 2, we added 2 here, right? So 2H is equal here, and then we have 2H, which balances the equation, right? Which is 2 hydrogen and 2 chloride, right? So we again here have to. Now, step 4 is that balancing the subsequent elements. Now, since we have already balanced chlorine here and then chlorine here also, we see that the whole equation is balanced, right? So when we look at step 5, we check the correctness of the equation. So the equation now is Zn plus 2HCl gives us ZnCl2 plus H2, right? Now we look into how we can make it more informative, that is by stating physical states of substances, reaction conditions, evolution slash absorption of energy, or kinetics of the reaction. For example, let us take the example of magnesium reacting with sulfuric acid, right? So when we say that magnesium reacts with sulfuric acid, magnesium is solid, right? uh, Reacts with H2SO4, that is in aqueous form. Its state arrow MgSO4 aqueous solution plus H2, that is gas, evolves, right? So this is making the chemical equation more informative by adding the physical states of substances, right? And then showing if the gas has evolved or not. Now, another important thing is that this here means that a reaction is reversible, right? For example, nitrogen reacting with hydrogen in gaseous form is reversible in and which gives ammonia, right, in gaseous form. Now, moving on to the next slide, we have types of chemical reaction. Now, when we talk about types of chemical reaction, the first one that comes is that combination reaction, right? Which states that a reaction in which two or more reactants combine to form a single product is called a combination reaction, right? For example, burning of coal, uh, which which is carbon plus oxygen gives CO2, right? So we see here carbon is a solid substance, oxygen is gaseous, and CO2 is gas. Right. So here, two or more reactants are combining to give out a single product. Right. Another example we take here is calcium oxide reacting with water to give calcium hydroxide, right, in aqueous form, plus heat. Right. This is the product here that is single. Okay. And then there is decomposition reaction, a reaction in which a single reactant breakdowns to form two or more product, right, is known as decomposition reaction. And on the basis of energy required, this reaction is divided into three types, that is thermal decomposition, electrolysis, and photolysis or photochemical decomposition. When we talk about thermal decomposition, we take calcium carbonate under heat, which decomposes using energy, right? Heat is a form of energy. Let's keep that in mind. So when we take heat in this reaction, it breaks down into calcium oxide or decomposes into calcium oxide and carbon dioxide in gaseous form. Right. What was the definition of decomposition reaction? That a reaction in which a single reactant break down to form two or more products. Right. Single reactant giving out first, that is calcium oxide, and then the second, that is carbon dioxide. Now moving on to the next, that is electrolysis. That is reactions involving the use of electrical energy for decomposition of the reactant molecules. Right. So we here see that in this reaction, electrical current is used in a sodium molten sodium chloride solution. Right? That is in liquid form, which is molten sodium chloride. It is not a solution; it is in liquid form. So when we pass electric current, we get two two things, two products. That is, first one is sodium, and second one is chlorine. Now we move on to the next one, that is photolysis or photochemical decomposition, where we see that sunlight is taken into the reaction, in which silver chloride, that is white in color on the reactant side, decomposes into two. First one being silver, which is in grayish white, and then the second one is chlorine, which is yellowish green in gaseous form. Right. Second one, which is in yellowish green in gaseous form. Okay, moving on to the next one, that is displacement reaction. These are divided into two types. Now the first one is single displacement reaction. As the name suggests, that reaction in which a more reactive element displaces a less reactive element. For example, we here have zinc reacting with copper sulfate and then giving a zinc sulfate solution and copper metal. Right, so zinc here is a more reactive metal than copper, and then it displaces copper from this uh, particular reactant to the product side, right? And then Cu is left apart, that is copper. Now another uh, reaction under displacement reaction is double displacement reaction. That is reaction in which two different ions in the reactant molecules are displaced by each other, right? So in single displacement, there was one more reactive element displacing the other. In double displacement, there are two elements reacting, different elements. And in this, we take the example of uh, silver nitrate, which reacts with sodium bromide to give a silver bromide yellow precipitate. Here, this means precipitate, right? And this is yellow in color, and also which gives sodium nitrate. This is sodium nitrate, right? So there is simultaneous or say different elements displacing different elements and forming new compounds or products, right? Now the next reaction that we'll be looking into is neutralization reaction, in which reaction the acid reacts with a base to produce salt and water, right? So here NaOH is a base, and HCl, as we know, is an acid, reacts and gives sodium chloride, that is a salt, and H2O, that is water. That is neutralization reaction. And then moving on to the next one, that is oxidation and reduction reactions. First, we'll look into oxidation reaction. Now, oxidation reaction is, is simply, we will look into that oxygen, when oxygen is added into a substance, it is an oxidation reaction, right? And then process in which hydrogen is removed is oxidation again, or in which substance loses electrons. Now, the opposite would be reduction. That is, oxygen is removed, hydrogen is added, and substance gains electrons. Now, let's take the example. Let's look into the examples, right? So here we have sodium, and in the sodium, there is addition of oxygen as stated here. So it becomes sodium, it becomes into sodium oxide, right? And then we have substance losing electrons, right? So this is Zn2 plus ion, and we have two electrons that are separated in the product side. Now when we look into reduction example, यहाँ पे सोडियम जो है उसमें हाइड्रोजन ऐड हो रहा है, ठीक है? और अनदर एग्जांपल, सब्सटेंस गेन्स इलेक्ट्रॉन्स, जो Zn2 प्लस का आयन है वो दो इलेक्ट्रॉन गेन करता है और Zn बनता है, दैट इज ऑपोजिट ऑफ ऑक्सीडेशन. Now what is redox reaction? As the name is, redox looks like it's a combination of oxidation and reduction. So the definition would be reaction in which oxidation and reduction takes place simultaneously. For example, we have copper oxide reacting with hydrogen to give copper plus water, right? So in this we have addition of addition of oxygen, which is oxidation, and then we have removal of hydrogen as reduction. Okay, and then moving on to the next slide, we look what is oxidizing agent, and then we have reducing agent, right? So oxidizing agent is substance that helps in oxidation of another substance. So here CuO help in oxidation of another substance, right? So CuO help H2 का oxidation. So this is an oxidizing agent. वैसे ही reducing agent का भी उल्टा definition होगा, that is substance that helps in reduction of another substance. So it helps CuO in reduction, so this is reducing agent. For a simple, if you look here, is that if a reactant is going into reduction, it will be an oxidizing agent, and if a reactant is going into oxidation, it will be a reducing agent, right? So this is reducing agent and this is oxidizing agent. Now moving on to the next slide, we have exothermic and endothermic reaction. So exothermic reaction example is respiration. Now looking into the definition, ये reaction होते हैं are accompanied by the evolution of heat. So these are called exothermic reaction, right? Suppose जब आप रेस्पिरेशन होता है बॉडी में, तब ग्लूकोज ऑक्सीजन के साथ रिएक्ट करके कार्बन डाइऑक्साइड फॉर्म करता है विद वाटर एंड रिलीजेस एनर्जी. एज आई सेड अर्लियर, एनर्जी or heat is a form of an energy, right? Heat, sunlight, or electrical current is a form of an energy. So this is exothermic reaction, in which reaction is accompanied by evolution of heat. We get energy here in this reaction, as you can see, right? So moving on to the next slide, that is endothermic reaction. It is opposite of exothermic. So इसमें absorption of heat or energy होगा रिएक्शन में, तब जाके रिएक्शन टेक प्लेस करेगा, राइट. फॉर एग्जांपल मर्क्यूरिक ऑक्साइड रिएक्टिंग विथ हीट, we get mercury and oxygen, right. It is also called hypothermic reaction क्योंकि energy is needed for reaction to occur, and then which is less than the total energy released. As a result of this, the extra energy is absorbed in the form of heat, right. So for example, photosynthesis is one such example of endothermic reactions. Now when we move on to the next slide, we have oxidation reactions in everyday life. Now as you have seen, when oxidation occurs, there is adding of oxygen, right. So in corrosion, that is one of the examples of oxidation reactions in everyday life, or key points in oxidation reaction. It is a phenomena due to which metals are slowly eaten away by the reaction of air. हम जानते हैं कि एयर में ऑक्सीजन होता है, and water also has oxygen and chemicals present in the atmosphere. Example, rusting of iron. Second, that is formation of green layer over copper. And then there is another example, that is tarnishing of silver, right. So rusting of iron takes place like this. As you can see, this is iron, and this right here is the air around iron, right, which gives us hydrated iron oxide, which is rust. Okay, so this is the chemical equation of rusting of iron. Now when we move on to formation of green layer over copper, we see that new copper vessels forms a green layer of basic copper carbonate after some time due to reaction of copper with the air and moisture. Okay, so these are some of the examples of corrosion. Now what are the effects of corrosion? We see here that it causes damage to car bodies, bridges, irons, and railings and ships, right, because it reacts with the air outside. As we have seen oxidation earlier, that oxidation is addition of oxygen, so it reacts with the atmosphere outside. Now there is an exception to this, that is the aluminum, which is a reactive metal, reacts with air to form aluminum oxide, which further prevents the corrosion of the metal, which is known as auto protection mechanism, right. uh, which is sort of self protecting from further corrosion. And talking about other things, that is prevention of corrosion, we see that we can prevent it by painting or greasing, that is creating a barrier around the metal, right. So that is one of the preventive measures that you can take, or use stainless steel as another measure, right. Moving on to the next slide, we have rancidity. Now rancidity is as simple phenomena as possible because it is a process of slow oxidation of oil and fat. ठीक है, जैसे कि अगर आप खाना खुले में छोड़ देते हैं तो वो थोड़ी देर के बाद ओडर देने लग जाता है, नॉट इंस्टेंटली, बट अगर आप उसे ज्यादा देर तक बाहर रखें तो, राइट. एज द डेफिनेशन स्टेट्स हियर इज दैट it is a process of slow oxidation of oil and fat, which are volatile in nature, present in the food material, resulting in the production of foul odor and taste in them. So, ये होता है aerial oxidation की वजह से when cooked food items are placed open for a long time, right? For example, जब आप पानी और चीज को बाहर रख देते हैं, that it gives a small foul smell. Okay, now how do we prevent rancidity? We can prevent it by packaging the food fridge में रख के at low temperatures, or pack the food like kurkure, and then these are kept under the like a packed solution with nitrogen gas instead of air. because air में oxygen होता है, and then it can react with the food, and then you can have another odor smell, right? Which is bad. Avoiding the food material and cooked food, keeping in direct sunlight. That is one of the preventive measures that we can take. And then by adding antioxidants, that is example like butylated hydroxyanisole, to prevent further rancidity. With this, we come to an end. And thank you.